Good afternoon, everyone. Welcome back. Thanks for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, the science and technology channel.
Yeah, and I was just telling Steve before we went on that I'm a little skeptical about this. Skeptical? Is that the right word?
You can do it, Scott. Skeptical.
Skeptical, there you go,
Like
about this story.
spectacle.
This reminds me of the story of, have you all heard of Jack and the Beanstalk? But anyway, we're going to talk about it. It has to do with growing some fungi and growing vegetables on Mars. So here we go.
Scientists from the United States and Brazil are exploring how beneficial fungi could turn Martian and lunar regolith into fertile growing media. You're on the fourth human mission to Mars, and you've been tasked with establishing the first self-sustaining food crop on a Martian settlement. You're nervous because you're using a new type of fungi called beneficial fungi, sounds beneficial, which you're told will help enhance Martian regolith, enabling it to be used for growing crops. Would you like to know more?
Okay, you were privately told that doing this will not only get a high school named after you, oh boy, but you will also successfully feed future settlers without the need to bring food from Earth. But you really only care about having your name on the high school.
Makes sense.
Yeah, that's me. While growing crops on Mars using fungi might be decades away, this hasn't stopped an international team of scientists from the United States and Brazil from pushing the limits of enhancing crop production through non-traditional methods. Okay?
So when I hear non-traditional methods, I think of sorcery. That's what I think of.
Okay.
I think of Frankenstein, a monster. Non-traditional methods.
Yeah, or what is it that? That's good. Sorcery is a good one, so we'll go with that.
With their findings recently published in the journal Frontiers in Astronomy and Space Sciences on February 28th of this year, the researchers discuss how a type of fungi called beneficial fungi could be used to convert the toxic and nutrient-absent lunar and Martian regolith into biologically friendly soil for crop production. Wonder what makes it toxic? Radiation?
So, okay.
Beneficial fungi are fungal species that support nutrient cycling in plants, soils, and other organisms.
Okay, one of the big problems we have on Mars, right, is that there's no water.
Oh, there's a polar
We
ice
found
cap.
ice.
There's that's water.
Okay, but we don't know how good this water is, right? We don't know how good this water is.
We got to find out. We got to take samples.
Yeah. So what are we going to do? Some test crops, test planting?
No, I would think like they said, this is the fourth man mission theoretically. So the first, second, and third, they're bringing back samples of the regolith, Martian regolith, and hopefully ice, frozen ice that's still frozen when it gets to the Earth, so that they can check it out.
So we're doing these studies, and then the next thing we're going to do is we're going to try to, that would be the clinical trial study, right? We're going to try and grow something on Mars.
Right, but I mean, it's not that easy. You're not going to take a plow and plow a field because of the temperatures there, and you're going to have to do it in a dome. So you're going to have to set up the dome first for habitat, and then plant your crops inside the dome.
Yeah, and that was probably on the second man mission, right? They're erecting these
domes. Will take a while. I think the dome will continue to be built over missions. It starts out small, and then each mission it gets a little bit bigger and a little bit bigger.
Okay. For the study, the researchers used a review article to focus on how the moon and Martian regolith are limited in vital nutrients for growing crops, specifically nitrogen, potassium, and phosphorus, and how to overcome this. Okay, so those are big deals right there, right?
Yeah.
The researchers discussed how several fungal species on Earth have been observed to promote plant growth through increased nutrient absorption while functioning under abiotic, which is non-living organism, stress, along with fungal species used on the International Space Station. Okay.
Abiotic stress is emphasized since plants are being grown using nutrient-deprived components like lunar and Martian regolith. Regolith is soil. To overcome this, the researchers suggest using arbuscular mycorrhizal fungi, AMF, which have been used in botany since the mid-19th century. Of course, I mean, you all knew this. I'm just stating a fact here. And function by acting as a microscopic extension of a plant's root system.
The researchers note that while future studies are needed to address knowledge gaps in growing plants in real-world applications, specifically real lunar and Martian regolith, they express optimism that fungi can be used to help produce plentiful crops using lunar and Martian regolith in the future. Well, of course they're optimistic, because if not, they're not going to get no more money.
Not going to get
right?
money.
That's
Yep.
right.
The study notes in its conclusion, quote, including plant growth promoting fungi into lunar or Martian regolith-based agriculture systems would present a strategic enhancement to space crop production and the establishment of human settlements beyond Earth. Fungi such as trichoderma and the various AMF, glomeromycota, stand out for their ability to relieve abiotic stresses, mobilize essential nutrients, and potentially improve the physiochemical structure of regular substrates. This is basics here. These microorganisms offer a promising biotechnological tool to transform the regolith environment, inorganic composition, and positively impact the engineered microbiome introduced to inhospitable substrates. End quote.
Wow.
It sounded scholarly.
Yeah, a lot of big words in that one. I think they were paid for letters and words in that.
I'm not sure. Why didn't you get this paragraph, Scott?
I don't know, but I'm glad I didn't. I was struggling just listening to you read that. So, using lunar and Martian regolith to grow crops is a practice called in situ resource utilization, also known as living off the land. Okay, I can relate to that. This involves using local and available resources to procure mission essential components without the need for outside supplies. Okay.
In the case of the Moon and Mars, using available regolith, which is completely devoid of nutrients to grow crops, and combining it with beneficial fungi could mitigate and possibly completely negate the need for shipping soil from Earth to grow food. I wonder if you'd have a vampire in that soil while you're shipping it. This could drastically reduce the financial and logistical burdens of shipping entire food supplies from the Earth to the Moon and Mars.
Using ISRU for future human missions to the Moon and Mars is part of NASA's Moon to Mars architecture, with this study adding to a growing list of research dedicated to ISRU and specifically using lunar and Martian regolith to grow crops. Most recently, researchers combined 1 gram of cyanobacteria with Martian regolith stimulant to grow 27 grams of duckweed. We talked about duckweed, didn't we? Didn't we talk about duckweed a while back?
No, yeah. And this was, I don't know, the regolith simulants. So they're simulating Martian regolith.
Yeah.
Okay, keep going.
Oh, you want me to finish that? Okay. Yeah. How will beneficial fungi help grow crops in Martian regolith in the coming years and decades? You ask, only time will tell. And this is why we science. Okay. Send me your money.
Yeah, give me your money. Or maybe there's a billionaire corporation out there that wants to exploit the minerals, and they got to find a way to put their drillers and their.
Well, yeah, you think about it. All the people that are growing stuff here, they want to grow it there too, right? They already know how to grow stuff. They just need to figure out how to grow it where you can't grow it. So,
I learned from the movie The Martian that when you grow crops somewhere, then you've colonized that place.
Did you ever see the movie Soylent Green? No? You got to see that movie. That's what everybody survived on. Soylent Green.
Oh.
Yeah.
Yeah, in the 100, they survived off algae for like 5 years. That's all they ate, algae.
That's kind of what Soylent Green was. It was like a little wafer, if I remember correctly. So, not too appetizing. Yeah. But hey, If you're going to go to Mars, you got to deal with it, right? There's not going to be any McDonald's on Mars for a while.
Well, you could eat each other. I mean, like the Donner Party. I mean,
well, yeah, but then what are you going to do when you get down to the last body? You can eat
right.
yourself.
We'll worry about that on the last body.
Okay. All right, folks. There
Right,
you go.
folks. Thanks for joining us.
Take care, everyone. We'll see you tomorrow.